Hello everyone, thank you for having me here. It is an honor to be here with 22nd International Conference on Intelligent Systems Design and Application ISDA 2022. I Virendani representing as corresponding author from Computer Science Engineering Department, Shri Vaishnav Vidyapit Vishwavidyalay, Indore, and my co-authors are Ms. Priyanka Kokte, CSE Department from SGS ITS, and Ms. Jyotsna Goyal, CSE Department, Sage University, Indore. Here I am going to present a paper titled A Novel Approach for Classification of Real-Time Data Stream to Reduce Query Processing Time. The entire presentation containing different slides which describe our research work. Next slide is abstract, which will give you short overview of this paper work. Abstract. The difficulty of data analysis and decision making becomes more difficult as the volume of data grows. To put it another way, processing big amounts of data necessitates many resources to analyze and provide a result. Big data is a term that refers to an environment that is used to process enormous amounts of data and analyze them. However, the query answer is generated with a significant delay if the traffic is sluggish and data block size is large. To optimize the delay response, considerable effort must be made to improve the performance of large data systems. This paper is proposed method based on streaming data mining for overcoming this delayed data response. The proposed technique contributes to Twitter stream collection, data preprocessing, and translation of unstructured data into structured data features and data stream. Classification utilizing the group learning concept for stream text data. Even when a single pattern appears for query processing, this method optimizes query processing speed and generates responses in less time. Introduction. Typically, non-stationary data generating processes result in ordered, perhaps endlessly sequences of data points known as data streams. Data mining techniques that are often used with data stream include clustering, classification, and frequent pattern mining. New algorithms for various sorts of data are suggested on a regular basis, and it is critical to properly examine them under controlled settings. Data mining techniques that are often used with data stream include clustering, classification, and frequent pattern mining. This data must be utilized for a range of analytics, including correlation, aggregation, filtering, and sampling. In the data stream concept, part or all of the input data to be processed is sent as one or more continuous data stream rather than as random access from disk or memory. Hundreds of data sources create streaming data continuously, and they generally deliver records in minute pieces, order of kilobytes. The inclusion of certain data in traditional stored relation is not precluded by using the data stream paradigm. Join between data stream and stored relational data are frequently performed using data stream queries. As a result, we eliminate any possible transaction processing difficulties that may develop because of concurrent modification to stored relation and data stream processing. Literature survey. First, Chen Lo et al. Focused on data intake and query processing for LSM-based storage system data utilized for a variety of purposes. The author first suggests and test a set of improvements for efficient based point lookups, extendability, applicability of LSM-based secondary index dramatically. Second, Mahmood Hassan et al. Introduced Twitter News Plus, an event detection system that uses customized inverted indices and an incremental clustering technique to discover large and small noteworthy events in real time from the Twitter data stream at minimal computational cost. The implementation of de facto standard Hadoop MapReduce as well as framework Apache Spark was emphasized by Khadija Aziz et al. After that, the authors used Spark and Hadoop to run experimental simulation to assess a real-time data stream. Proposed system methodology: collect stream data to data classification, then group structure development, then query interface in figure number 1. There are several types of data format existing in data mining constantly works with a variety of data types and their forms. We divide the data format into two main groups: static data and dynamic data. Based on present situation, data is provided in a set of volume data not increased in a timely way are considered static. The dynamic data, on the other hand, are those that constantly rise with time. Such data are sometimes referred to as time series data or streaming data in the literature. The data from the live feeds are collected using an extra method. Additionally, Twitter is a live stream data source, and Figure 2 shows the strategy for gathering data from this source. Now, next slide, gather data stream. The depicted graphic assumes that Twitter is the source of stream data. The query API that Twitter offers may be used to obtain data directly from the social media platform. After the user's account access is authenticated, the local Hadoop storage is configured into Apache Storm architecture. This gives users the option to query the Twitter server for tweets using the Twitter account. A file in the HDFS directory serves as a temporary storage location for the server's answer to the query that is further employed for categorization purposes. Classification of data. Data categorization is a method for grouping similar patterns of data by identifying the pattern in data. As a result, the acquired data must be processed to extract certain attributes that will allow the real group of data to be recognized. However, any classifier may operate directly on static data to produce more accurate analysis. As a result, the categorization process must be modified in accordance with the data source interface. The classifier model must first be discussed before any changes to the classification technique are discussed. The C4.5 decision tree method is used in this experiment for categorization. Unstructured data must be modified to apply the method because the data set only uses structured data at the moment. Figure 3 shows the steps involved in converting data from an unstructured to a structured format. The system receives the created data as input. The unstructured nature of such data makes it potentially noisy for an algorithm to process. As a result, the text stop words are first eliminated. Stop words like is, am, are, his, the, and so on regularly appeared in sentences without having much of an influence on the finding of subject or domain. The procedure described below is performed to get rid of them. Next slide. Input is collected data D, stop word list, and output is defined data R. The process for I equals to 0, I less than equals to HW length I plus plus, R equals to find and replace dr HW of I, and then step 3 end of for loop, and then return to R. Data must now be tagged using the NLP parser. Once the stop words have been removed, the NLP parser takes the input and extracts the information about the parts of speech. In the following stage, the features from the speech data are extracted using this portion of the data. The frequency of each speech component is calculated in this case and provided in a data table. Table 2 provides an example of the extracted feature. For determining the base set of data, the calculated characteristic can be used with the decision tree, create tree data structure. We thus refer to earlier assertion that we use the binary classification process, leading to introduction of a new instance of the classifier between two distinct classes. Table 2 example features: noun, pronoun, verb, and adverb. Given table is used to describe the stream data categorization process. Classification of sample. Input is classifier C, pattern data D. Output is group data G. Process step 1 while D not equals to null. Step 2 fetch pattern. Step 3 if new class appeared, then if count is equal 0 equal initialize the classifier instance. Classify using update count equals to count plus 1. Or B part else if count equals to 1. Classify using update count equals to count plus 1. End of if loop. Step 4 G equals to C. Step 5 end of if loop. Step 6 I equals to I plus 1. Step 7 end of while loop. And step 8 return to G. Accuracy. The accuracy of a classification approach is calculated by dividing the number of correctly categorized patterns by total number of patterns created for the classification result. As a result, it may be used as a metric for how well the categorization method was taught. Figure 3 is for accuracy comparison. Graph depicts the accuracy of suggested live data stream classification method that has been implemented. The figures x-axis depicts the number of times the algorithm was performed during classification and tagging, while the y-axis depicts the result in terms of accuracy percentage. The performance of suggested model according to obtained findings gives more accurate outcome. Furthermore, the accuracy of the data categorization model is stable even when the number of runs is varied. Next slide, error rate. Error rate of a system is defined as the number of data and misclassified samples during algorithm classification. This can also be calculated using the formula below. Graph depicts the applied classification methods, comparative error rate, throughput, multiple execution. The proposed classification performs well and efficiently, and as the volume of data rises, performance decreases. As a result, the suggested classifier performs more accurately and efficiently than the default C4.5 data categorization approach. Next, memory utilization. The amount of system memory used is sometimes refers to as system's space complexity when describing algorithm performance. Quantity of memory used is determined by the amount of data in the main memory, which has an impact on the computational cost of running an algorithm. X-axis depicts number of algorithm tests, while the y-axis depicts relative memory uses during execution in kilobytes. According to the presentation, the memory of both implemented result memory demonstrates the system's complexity, with typical C4.5 requiring less storage than the suggested data type classification method. Next slide, time consumption. The amount of time required to categorize all the live stream data is known as time consumption. The time consumption of the proposed algorithm is given using graph. Performance of suggested approach according to the comparison results analysis minimizes the time consumption. As a result, our suggested method of stream data categorization of Twitter data employing augmentation of decision tree is better and more efficient. Conclusion. Normal computer approaches cannot effectively and efficiently process the enormous amount of data. The model delayed the data response procedures if there was less data. To decrease the time it takes for user queries to be answered, it is necessary to develop a new method that operates on data streams and provides frequent response to user queries. The few data may respond quicker. Hypothesis is applied to find a solution for the problem that is being addressed. The Twitter live stream data is chosen since the suggested approach is based on streaming text data. This categorized group data are immediately stored in a high structured database. The conserved data may be utilized within any rapid response application or the query interface to provide the end answer user. References are follows, which was includes to prepare the entire proposed work. Thanking you all. Thank you.